All right, so now we are back in our foo directory, and now we are going to talk about sourcing files. This is how in Bash I can sort of have like a library of functions. Now Bash is special because it can just execute external commands, so I could just have a whole directory full of commands and I can execute them no problem, and I could totally do it that way. I could also make functions or variables or anything like that in its own file, and I can source it in. Kind of like if you're in Python, you can import. If you're in C, you can include. Rust has all those beautiful crates. It's sort of like that in all those different languages. I know JavaScript has like a whole require, but then replaced by, what do they use now in JavaScript? Import? I don't know. I haven't written JavaScript in forever. But let's go ahead and do that in Bash. So to get started, we're going to write our own little program, and we're just going to call our program say hi. All right, so say hi will be a very simple program. We're going to follow the whole greeting thing that we've been doing a lot during this. So we'll save this, chmod +x, vim it. There we go. Now we can do a couple things. We're going to want to greet Dave. We're going to want to greet John, and we're going to want to say goodbye to Buddy. Now here's the thing. We don't have greet and goodbye as commands, so we have to define them up here. So let's go ahead and make some functions here. We'll make a greet function where we will say echo hello $1. There we go. And then we'll make a goodbye function where we will say echo goodbye $1. There we go. So now we have our two functions here. And if we run our script, it should just say hello, hello, and then goodbye. There you go. Perfect. Hey, works just fine. Now here's the thing. What are we talking about with sourcing? Well, we can take these functions and we can put it into a different file and we can make it accessible to any of our bash scripts in this directory. So let's go ahead and do that. Let's go ahead and make a dir called lib. So now we have a lib directory where we will put our library of like functions and stuff. So let's go ahead and cp say hi into lib greet. So we will make the library called greet, or we'll call it greetings. How about that? We'll call it the greetings library because it has a whole bunch of greetings. It also can say goodbye. Probably should have thought of this name before I started writing it, but hey, here we are. Let's open up that library. Now we have the greet function. We have the goodbye function. Let's go ahead and delete those. So we just have function declarations. We can run that. We can run lib greetings and it will define those functions and nothing will happen. That's what it does if you run it, but we're not really interested in that. We want to source them. So let's go back to say hi and get rid of the definitions for those functions because they're already defined in our greetings library. And let's go ahead and source that. We can use the source built in and we can source lib greetings. So now if we were able to successfully source that, there you go. We have access to those functions. Remember we talked about bash -x? We could do that here and we can kind of get an idea of what's going on. We source lib greetings, then we call greet Dave, and then there you go. It works because the function was defined in that sourced file. That's super nice. That's super convenient. You may have also seen this instead of the source keyword. You may have just seen a dot. This also works. And this will work exactly the same. Now in other shells out there, I believe ZSH is a shell where dot and source are slightly different. They have different semantics on how files are resolved. I believe that's the case. I could be wrong here. But in Bash, that is not the case. If we do a help on source, we can see that there's a whole big long help message. That's super nice. And if we do help on dot, you can see that we get the exact same message. They are exactly the same. There's no difference between them. Source and dot in Bash are exactly the same. Dot is what you'll see in POSIX shell scripts. Source, I believe, might only be in like Bash or other shells like that. So dot is definitely more portable if you're trying to target something that's not Bash. If you're in Bash, you can use source. I tend to use dot. The other thing about dot is that it could fail. Imagine if I had a typo here. If I had like greetings with a Z, well, that's not going to work. So let's go ahead and run that. And we can see that, oh, we got no such file directory, and then it failed to run all that stuff because it kept trying to go. So we could do this. We could say like, if not source, then we could write that and we can catch an error saying like, uh-oh, greetings wasn't found. You could also do it in one line. I've seen people do really simple things like this. I do it myself. This. So basically we're saying, hey, try to source this file. If it fails, then just exit with an error. There's nothing else we can do here. So if you run this now, you can see that we try to source it. We don't move on. We don't run any other commands. We just try to source it and we move on with an error. The nice thing is if we change this back to an S, then everything should work and we get our greetings. Hey, that is super awesome. The cool thing about this is we have our say hi script here. We could also have, we could cp say hi to, I don't know, say bye. And now we have a new script here, but it sources the same library. So we could just change this all to goodbye. There we go. So now we have our say bye script and we can modify our say hi script to only ever say hi. So say hi, we'll say hello to everybody. Say bye, We'll say goodbye to everyone. Even though they use the same underlying function on the hood, that's a way of being able to reuse code easily in Bash, and they're functions, so they're fast. There's no forking out to external programs here, which is super nice. Another thing you can do here, which I find really cool, is Source has this option of -p, which is really nice. It takes a path style argument. If you remember, path has a bunch of paths separated by colons. You can do the same with Source with a -p. I believe this is new. I don't know when this was introduced. I say new, it could be 5 or 10 years old. Just keep that in mind. But the nice thing about that is if we go to our say hi script here, instead of having to hard code lib greetings here, we could do something like this. We could say libdir equals, or libdirs, we can specify multiple ones, equals /lib, just the name of the directory, and then you can pass it as -p here. So hopefully this makes sense what's happening here. But I specify libdirs to be /lib, and then when I source, I can give it as -p here, and I can just give the name of the file that's in that directory. So basically, Bash will go through, search through every directory that's here, separated by colons. There's only one, but it will search every directory here for a file named greetings, and if it's found, it will source it. So this will work exactly the same if I run say hi. It'll work exactly the same. This is super nice because you could say override this. If you were making a library in Bash and you wanted like a custom version of source, you could say like my source, make a new function called my source, which runs source -p /lib on $1. So now, instead of having to specify this here, I could just say my source greetings. Hopefully this makes sense what I did. I overrode source. I didn't override it. I made a new function called my source, which just calls source under the hood, but already gives it the lib directory. So you can imagine this being somewhere else. Me, the programmer, I don't have to think about where the libraries are stored. They could be on different places. I just run this little my source thing and it pulls it right from the library. So if I run this, there you go. It works exactly how you'd expect it to. One last thing I want to talk about this, which is super cool, super useful. If we go into this library where we have greetings here, something you might want to do is test this stuff here. So you may be inclined to just make sure like greet works. Like I should be able to greet Dave and I should be able to say goodbye to John, right? I should be able to do something like that. Well, you don't want to put that there because now if I were to run, let's say bye. I'm in the lib directory. If I were to run say bye, you can see that it put those things at the top. So any code you put in the library will get run. Source is effectively saying, hey, go to this bash script and run all that code as if it's in my current file. It's very similar to like include in C. So you don't want to put code that really executes here. You just kind of want to put like definitions of things. Maybe you want to put code that executes here, but just be mindful that it will get executed anytime someone sources your code. So Python has this beautiful thing. You may have seen it. If name equal, I think it's this. I may have had that right. I haven't written Python in a while. But if you look at that kind of syntax, you know that, oh, this code will only run if this file is being executed directly. If I'm just being sourced in or I'm being imported, it won't run. So Bash has something similar. It's a wild, gnarly syntax. I'll go and find out the source of this because I actually want to know where I originally found this from. I want to say it was one of the creators on the Bash wiki that linked to this. I love this syntax. This syntax is beautiful. It is so cool. And it's wild. So I'm going to write it and then I'm going to explain it. So there we go. If this thing is true, if this whole if statement is true, then we are being called directly. So this will only run if we're being called directly. If we run lib greetings, it will execute hello, Dave, and goodbye, John. If we just run our say goodbye, say bye, it won't print the hello, Dave, and the goodbye, John, right at the beginning. So it knows if it's being sourced or not. This is so clever. I was amazed the first time I saw this. So we have the parentheses here, which create a subshell. Again, I'll talk about that more later. The reason we create a subshell is so we can use the return keyword. Using the return keyword outside of a subshell or a function is an error. So we put it here. We don't actually return. We just check to see, are we able to return? We discard any errors. We don't want any error messages going to the screen. We just check, are we able to return? And then we negate the result. So let me explain. If we're able to return from this, then we are being sourced. If we are able to use the return keyword, then we are being sourced. If we're not able to use return, then we are not being sourced. So we just negate it. If we're able to return, If the opposite of that is true, if we're not able to return, then we're being called directly and this stuff gets executed. So it's one of those things where I can break down how it works, but just kind of memorizing the syntax is super useful, especially when you're getting started. So you can make library code, but you can have that library code actually do something kind of meaningful if you run it yourself. This is great for just like testing things, making sure your stuff works, stuff like that. So yeah, that's sourcing.